Ready to get started? Again, welcome to our webinar on S1000D compliant illustrations for those of you who just started. Our housekeeping rules for this webinar is all attendees will be muted for the duration of the webinar. If you should experience any technical issues, use a little chat box over there on the side to let us know. And then use the question functions to communicate with us. You can post those questions at any time that these questions pop up. We have some information available over in the handout sections. We invite you to, there are little PDFs you can drag and drop to your desktop. We invite you to grab any of those that look interesting. And then questions will be answered at the following the main part of the presentation, or if we run out of time, we'll get back to you with email. For those of you who are not familiar with Larson Software, we're based in Houston, Texas. We're founded in 1984 as graphics technology experts and been doing that for 30 years. We develop powerful, innovative graphic software, both end user products and toolkits based on open standards. We've promoted the CGM usage from the time it was first published with a free CGM viewer, which we just recently replaced with a subscription version that's online on our web store. We're the developer of the first HTML5 CGM viewer that eliminated the need for plugins. Remember the CGM Open Foundation. Larson Software Technology simplifies the graphic workflow for technical publishing professionals. So with that introduction said, I will now turn it over to David Manock for the main part of our presentation.
Thank you, Don. Welcome everybody today. Hopefully you can all hear us. I have one question came up, somebody couldn't hear us, but I'm assuming there was only one, so I'm assuming everybody else can. So welcome everybody. So the agenda today, firstly, just want to give you a very, very brief introduction to S1000D, the specification, and how graphics kind of align to that. And then in more detail, we'll go and look at the 2D illustration guidelines. We'll do a brief demo. Then we'll look at 2D file formats. We'll then look at interactivity, hotspots and so forth, and we'll have another demo. And then we're going to go on to 3D guidelines and file formats. This is pretty new in the specification, so we're going to go through that. And then we have some more demos interspersed. And the final demo, we're going to preview some new technology, which we think you'll like. So please stick around, and you'll be the first to see some technology we've been working on. And then we'll summarize, and we'll have a Q&A session at the end. If you have any questions, just please post them as we go along. We have quite a large audience, so if you want to get your question answered online, live, then please post them as soon as you can think of them. Otherwise, we'll get back to you by email. So the specification, I'm assuming everybody on the call probably has some exposure to this spec, or is beginning with it, or is already on a project. But it actually started in the 1980s, the specification. It first came out, but was on a very few different projects, mainly defense projects. The main concept was to really provide a way of putting information out there in a modular form. So rather than a book-based system, it was a data module. So small portions of data in modules that people could access more easily and update more easily. And each one of these data modules has a unique ID. And that's everyone that exists out there. There's every data module is a unique ID. So the objective was to have a more flexible method of managing and publishing documentation. So they have a CSDB, which we will mention later on, which is a common source database, which really is designed to manage both data modules and the graphics of the project. So today we see S1000D is widely adopted globally in lots of different countries, and it is also adopted by the commercial aerospace industry as well. So it's used on like the 787 and so forth. We obviously, from a graphics point of view, see that as a critical component of the S1000D deliverable, and it has its own unique requirements. If you're interested in the spec, you can go to s1000d.org. You can also download the specification there as well. There's no charge for it, so you can easily get hold of the spec. And we've just actually, I think it was this week, had confirmation that the next user forum, S1000D user forum, will be next year in Washington State in Renton on June 20th to 22nd. So fingers crossed, everything works out and we have that event. It's been some time. So this presentation is based on issue 5. I think the issue 5 is mainly had, it had quite a lot of different things gone into it, but not from a graphics point of view. The main thing that went in from the graphics side was a bit more detail on the 3D. So, and I'm only saying that because a lot of the projects are probably using issue 4 still of the specification. What I've tried to do is give you pointers to the chapters that we're talking about today. Don't rush to write this down, or you might want to take a screenshot, but this presentation will be available probably tomorrow on LinkedIn, so you'll be able to download it. So I thought this might be useful. It's probably a lot of it's common sense, but I thought it'd be good just to kind of put down in a kind of a schematic the kind of process you might go through to create an illustration in S1000D. I think primarily today, like new illustrations are really been conversions from 3D CAD data. So, and then from that, we would get a 2D illustration where we'd add interactivity and annotations. But we'd also have legacy illustrations that have already been created that we need to modify. And these could be vector or raster scanned images, and they could come from various sources. So once we've added the value or modified them, we then would go into a 2D format like CGM or SVG or raster. And then for 3D, we'd need to have an appropriate format to go from there. So what I'm saying is that we might not necessarily convert it to 2D. We might go and use it in a 3D form in a project. Once we have the files, they would be stored in the CSDB, and then they'd probably finish up in the IETM to deliver it to the customer. So from a graphics point of view, you're going to need a 3D viewer if you've got 3D information and a 2D viewer for 2D. So pretty self-explanatory. But that would be part of the IETM technology. So firstly, I want to look at illustration guidelines. These are quite detailed in the spec. Obviously, I cannot go through all of this today, but I think it's good to give you an overview of what some of the main requirements are. So again, we have the chapter. So just to give you a point of reference, if you're going through the spec is enormous. So this is just one part of it, as you can see by the actual chapter and section number. So we have like a high level, and then we have a more detailed illustration guideline. But at the high level illustrations, again, common sense, we need to communicate simply and clearly a way of actually enhancing the text. So how we would disassemble something, maintain something, spare parts, illustration, etc. So we're looking to visually enhance that technical information in some way which helps the user. So, and obviously this information then needs to be part of that data module as well. So as far as the two main illustration types are concerned, new illustrations, I think there's an opportunity to use the guidelines I'm going to show you in a second. But from a legacy point of view, then there could be a quite a high cost incurred if they don't match those. So certainly nothing's going to be thrown out, I don't believe. If you've got a lot of legacy and they don't comply to the rules, then I don't think it's a massive concern. So primarily, I think print is disappearing. Well, printed books are disappearing gradually, but you might still need to print them from an IETM. So the size of the illustration is not as perhaps as critical as it used to be, but you still might need to print from the IETM onto a standard page size, like A4 or page in the USA. So you have to take that into consideration, the output. So some of the rules are around the perspective view would usually be isometric. That's the chosen isometric projection is the chosen one of the S1000D community. They also have the illustration and page size, which we just looked at now. And also they specify line weights, line styles, annotations, symbols, and so forth. And obviously they need this a way of communicating the data that doesn't kind of detract from the main thrust of the illustration. So they're saying remove extraneous data that could confuse the user. They're usually monochrome, although you can use color as well. And there's actually a business rules decision point, that's the BRDP, where you can specify if there's going to be color used on illustrations. We'll talk about that a bit as we go along. Oops. Okay, so I'm not going to go into this slide, but this is just a sample of one of the tables that you will find in the spec that gives you all the line weights, then the line types. So as I said, this is quite detailed, the 2D side for the creation of illustrations. And also symbols. So we have different symbols that we can put into the illustration. So and these obviously are kind of pointing to details forward, back, and so forth. So there are standard symbols. And I think even if you're using legacy illustrations, then you should really follow these guidelines for symbols in S1000D. And you may say, well, this is a bit pedantic, but it is just really to standardize the information across the spec. So if people are moving around between different manuals and so forth, that everything is consistent in the way that it's done. So I did mention color, and there is a specific color palette, which I'll show you in a second. But there's some really good examples in the specification about the use of color. And I think a lot of this might have come from the commercial airline community. But you can see in the illustration on the right there that yellow is what's attached to the main assembly. Then light blue are actually the parts on the illustration. And then gray are the parts that are shown on subsequent illustrations, which also have a detailed arrow next to them, which means if you click on them, you would probably navigate to another illustration with this particular part on it. So as I said, some good examples in the spec of use of color. And the color palette it's not extensive, but it is the recommended palette for the spec. So I would say stick with it, and then you will be compliant. So what we did is we created a kind of template, which you can find on our website. Again, don't rush off and try and copy this down. Again, we'll send this out after the webinar. But you can download the actual file that we've created, which is a CGM file, so we'll need a CGM editor of some description to open it. But we hope you find that useful. So in the first demo, I'm just going to go to actually that file. So as I said, we created this just as a guideline for people. So we created all the pens that we associated with the spec, with the right line widths and so forth. We created the color palette, which we've also now put into our own software. So we've actually, the color palette is there immediately if you need it when you're doing the illustration. So we kind of created a custom color palette for S1000D. This is the ICN number, or information control number. It's not something we're going to go in today, but if you think of it as an equivalent to the data module code, each multimedia object, so it's not just illustrations, it could be photographs, it could be video, has to have its own unique code. So that's a kind of topic in itself, but again, that is in the spec, how to create the ICN code. But each illustration or multimedia object has to have its own unique code. So we hope you find that that useful. So as you can see, we have isometric on here and so forth. I'll just go to this illustration here. And we actually created a library as well of symbols that match the ones in the spec. in the spec. So I can just drag and drop those over. So you could also obviously put your own symbols in there as well. So we just tried to make that as easy as possible for you to comply using this particular software. Also annotations, we have an annotation tool, which we'll probably come back to later on. But with the annotation tool, we can just come around and annotate this up. So this is where, if it was an existing or a new illustration, you would need to add value to it with annotations and with symbols and so forth. So just to give you an idea of the process that you might go through after you've converted it from the CAD information. Okay, short demo. So I think it's good, rather than just see slides, that we do something live demo-wise. Now we have a bit of a dry subject, which is the file formats. There's a whole chapter on CGM. So believe it or not, there's like 14 pages on CGM. But I think some of you on the call will be also familiar with SVG. And you might be surprised to know that there is no mention really of SVG other than something you can use in the spec. So there's no profile for it. There's no guidelines around it. But we've done some work around it, so we'll explain that today. From a CGM perspective, this is still the only one that's documented. It's the only one, really, to my knowledge, that can be used as a deliverable to a project. So if you're working on a project for an OEM, then you would still need to probably deliver CGM files. From a hotspot point of view, interactivity, then you're going to have to use CGM version 4. So a lot of software still kind of has CGM export capabilities, but usually it's very low level. So I mentioned CGM version 4 was the first version really to include hotspot data, metadata. So you could easily add a hotspot to an illustration, which then could be interactive within the IETM. And there's also a web CGM profile or S1000D profile. So in theory, these files can be validated. So I validate it against the spec. So I know some in the commercial space, like Airbus and so forth, do validate CGM files to see they comply with the specification. They're not going to check probably line weights unless they have a validator that can go into those depths. It's more the profile itself. So even though SVG is not in the spec, it's become really important for a lot of organizations that are working with S1000D. And we took that on board early on. And so we've actually done a lot of work. All our software now supports SVG. And we'll talk about the main reasons that happened as we go along. Interestingly, SVG, or Scalable Vector Graphic, is XML encoded, as a data module is. And it's also open, so it's managed by the W3C and different working groups. So it's not proprietary to anybody. Some people might think it still belongs to Adobe, or it was Adobe's format, but it's actually it's open. The primary reason that a lot of our customers went to it was because of its native support in the web browsers. So you don't need a plug-in technology to actually view the SVG within Chrome or Firefox or whatever viewer that you're actually using, which is it's a big benefit, yeah. The first thing that we found kind of daunting with this particular format was, though, that it is enormous. The specification for SVG is really large, and a lot of it is not really useful for technical illustrations. So we actually have done a lot of work around that and had to really work with our conversion software and illustration software to support it with different outputs of SVG. And so as we go along, we'll see that how we've actually done that. So there are benefits to SVG. So it's based on XML, which is open as well. And in theory, it could be validated against the schema if one existed. I don't believe there is one at the moment. The caveats, or the things that aren't so good, is that for data exchange, it's just probably not designed. It wasn't designed to be interoperable. It was designed primarily as a display format on the web. So to round trip an SVG can be challenging. And the off-the-shelf schema that does exist is for the whole spec, so it's not just for certain elements. So you wouldn't really be checking it against anything to make it valid. So there would be a new schema required to actually do that validation. So what we did is we created our own profile. So similar to CGM has a profile, we created one for SVG and we called it Tech SVG. And we published it. It's actually one of the handouts. I think Don mentioned there's handouts that you can drag over, and one of those is the Tech SVG profile. It's a technical paper, but you might be interested to look at it. And the reason we did that was to try and make files interoperable. So in other words, that you could export them, import them, and they would be consistent, and they would be consistent within viewing environments as well. So you get the same outcome. You can see on the right that where Tech SVG lies, you can see the full spec. And this just gives you an idea of how many attributes it uses of the full spec. So one of the benefits is that it can contain hotspots like SVG. One of the downsides is it doesn't have a standard way of doing that. So that's what our profile did, gave a definitive way of writing a hotspot within an SVG. Some of the challenges, the file size can get large, although there is some compression routines. But the main kind of challenge is really around conversion. But we've done a lot of work to try and alleviate that. The next big topic really is the hotspots themselves, interactivity. With CGM, there's a whole chapter on hotspots. So, and this is primarily in version 4. So this is where we see that there's a tremendous amount of detail around CGM, but there is nothing really to help you with SVG. So what we've advised our customers to do is create the hotspots within the CGM file and then export to SVG, and that will give you a standard way of writing them out. So with the hotspot, you really have to have two files. You have to have the CGM itself with the hotspot embedded, and then that would link to the data module. You also have the option, instead of putting the hotspot information in the CGM, to have what we call a companion file. There's actually two choices now. There used to be only one. One is the XCF, which is XML, and also a pure XML file called IMF, which is fairly new, which I don't believe too many people are supporting at the moment. So the XCF file is obviously XML based. The graphic will need to be inserted. The CGM file needs to be inserted into the data module. And if the hotspot information is in the CGM file or in the companion file, you can then link it to the data module for that interactivity that we're talking about. The viewer, though, in the CGM viewer would need to support a companion file. So not all viewers do that. And obviously that wouldn't be something you'd be able to do with SVG either. So there wouldn't be any companion files for that. The IMF file, I advise, we have a blog on our site. I would say go to that. It's quite a detailed file format. It's almost the equivalent of a data module for illustration. So it could be managed in the CSDB, but it's not something I want to focus on today. It's a whole subject in itself. So basically, hotspots can be in the graphic and they can be in the companion file. So hopefully this illustration shows you or outlines how this is done. So the graphic, we would hotspot, in this case, the call out number 1. It'd have an ID, we give it a name, and then the same information now is over on this side where we have the name, we have the ID, and the application structure, and this is the data module. So this would forge that link between the graphic and the data module. So if your viewer supports it, then when we click on that in our parts list, for instance, then it would actually highlight the annotation in the graphic. So these are the two elements. If you have the difference with the companion file is this information here on the graphic side would be in a separate file, but it would still need to be in the data module to make the link. So here's the XCF. So it's very similar. There's the ID. So the ID is the key to do the linking between the data module and the graphic. And similar in the IMF file, the same thing applies, that we would need this information in this IMF file to link to the data module. So there has to be this unique ID again, which in this case is HOT001. So I'm not going to go into this IMF structure, but basically it's an interesting format. It has its own chapter in the spec. So if you're interested in using that, there is a dependency on the software actually supporting it, though, so double check that people are supporting it in their CSDBs and so forth. So second demo, I'm going back to VisX Edit. So let me just bring it up. I'm going back to this illustration here. And what I didn't show you earlier on was that, that the annotations have automatically been hotspotted here. So if I just turn on the view hotspots, you can see that these areas were actually hotspotted as I did it. So if I go to modify, that box that I actually showed earlier, this is a more detailed version of it, is that we can have a screen tip associated with a hotspot as well. So when the end user hovers over it, it will give him some more information on it, and it can have a link. It could have a URL to something else, perhaps to that other illustration if it was a detail. So for instance, if we made the detail a hotspot down here, then that would also be able to link to something else, another illustration perhaps. And finally on here, we actually put in an export to an XCF. So once the illustration is created with all these hotspots, then this will create that separate XML file. So that could be used as well if that's what the project requires, that separate file to hold the hotspot, the metadata information. Okay, so let's go back to the, oh, sorry, yeah, and what I was also going to show you is the fact that we can view these as well. So once we created that illustration, we have it here. We've actually put this into a HTML page. Although I said SVG doesn't need a plugin, this is actually a CGM because we have some technology to display CGMs without a plugin as well. So if you notice here now, we have the tooltips. we also have interactivity with the parts list. So this is how you can begin to build interactivity. So we're not showing it with a data module here. This is just pure HTML, but the same would apply if you had a parts list in the data module, then you could actually do the same kind of thing dependent on your viewer. And this works both ways. So if I click on the washer here, it will highlight it on this side. So you can have that dynamic graphic to parts list and vice versa. So thought it'd be good to show, the kind of the end product, although we're not showing it in a data module here. Sorry about all the window changes. There's quite a lot to kind of keep control of here. And this is all live as well. So we now come to 3D. So I've really covered 2D. 3D, we're going to go and look at the guidelines and the file formats. There's actually 10 pages on 3D within the spec, which I think came in version 5. There was a small section in version 4 of the spec. My opinion on the guidance that's in it is that I find it very high level. That there's not the detail that we have in the 2D, and so you have to kind of pick out the parts that are of interest to you, and we'll discuss it more as we go along. But I find it quite a high level kind of guideline. To me, going back as we looked at 2D production and 3D production, there's probably two steps. Step one is you gather in the data from engineering, which will be the CAD files, taking the elements you need out of the main assembly or the whole assembly, that subset of information that you need to actually create the illustration from. But ideally, you're going to have access to that 3D data. If you don't, obviously, that's going to be a big kind of block to actually reuse it to create new illustrations from. But once you've got that data, what do you actually do with it? So one of the terminologies that we have in the 3D world is a scene. So you would basically have a 3D model in a viewer, and then you would use that to try and get information from it that's useful as an end user. So you really need to think about how you're going to display that. Is it going to be dynamic? Is it going to have animation? Is it have a transparency and so forth? So there's a lot of possibilities with the 3D, but basically you really need to choose to use it where it's probably appropriate rather than everywhere. One of the recommendations is, again, which kind of is common sense, is that the source data is used to generate the 3D data. That means the CAD information. In other words, you shouldn't really go off and create your own 3D models in another piece of software if you already have access to the source data from engineering. So they have a section called Technical Solution. I was quite surprised that they don't recommend the 3D format as they do with 2D. That's my first kind of observation. So in what we've actually done is we imagine ourselves as you are an S1000D project, but we are approaching it from a software point of view. So we have to make some decisions about what we create or develop as a software company to try and come up with a solution that matches the specification. What is defined is whatever you choose, you should put it in the business rules, which kind of opens it up to use whatever you like. So you could use proprietary formats and file viewing solutions. As long as you write them down, then you could pretty much use anything you want, which I don't think is a great approach. And it seems to be opposed to what the spec's about. And the outcome could be going back to the early days of iTems, where there's a multitude of formats, a multitude of viewers, and there's no real interoperability for companies. It could be finish up trying to support 5 or 6 different viewing technologies and software. So I don't think it's a great place to be. So we would say definitely our guidance is use open formats. Definitely use open formats, which then preserves your data as well. So step one really is going around finding that data from your CAD department, which is probably going to come in, depending on the software that you're bringing it into. It might be native, or it could be more likely to be STEP or IGES or JT. So these are all open formats in the CAD world, and I think STEP's probably as good as any. It holds a lot of information, rich format, and usually a CAD department will easily create STEP files for you. So once we've got that data, what do we do with it? So let's go over. So this is a fairly new product we've developed called VisX Edit 3D, where in this case we have a step file that we've imported. We see the model tree on the right-hand side, so we can see all the different components in there. So what I can do is I can rotate this around, because obviously it's 3D, and I might want to actually start working with this particular area, which is the turbo. So I can bring out that particular area. Or in fact, let's try and bring out the whole thing. So let's show all. And I'm going to go back and let's bring it again. So with the tree view here, I can say I want the whole of that and then isolate that. And then I might, this is obviously going to be very quick and brief, so please bear with me. So what I might want to do now is explode this. So I can say manual, and I can begin to drag these parts away. So I can begin working with the model. So this is from my engineering area. I'm working with it from an illustration point of view. And now I need to create a 2D illustration of this. So I'm going to export. So this will be my CGM file. I'm going to put it on the desktop. It should actually open within VisX Edit, so I can open it up straight away. Hopefully it shouldn't take too long to process this. And then I can add those annotations and interactivity to it. So this would be where you would really be creating a new illustration. So what it's doing at the moment is it's removing all the hidden lines, and then we've got our isometric illustration, which we then can add our annotations to. So that's kind of one area. So that would be step one. We would take the illustration, create the new illustration from CAD, and bring it in to 2D, add our value, annotations and so forth, and then export it to CGM or SVG to take it into the CSDB and then into our IETM. Okay, so let's just quickly go back to the slides. Step two is, well, once we've got this so now we're going back to the 3D content, but we might now want to use it as 3D rather than export it to 2D. This was the chapter we spoke about at the beginning. And as I said, it is quite high level information. So they're saying really you should only really use 3D when there's a benefit to the user. It might be a complex maintenance procedure, so you might need to have a way of looking at it from different views to protect the user. It just that may explain it better along with the text. So, and it might need warnings and cautions appropriate to what's going on as well. So this would all have to be displayed in the 3D viewer environment. So I mentioned there's the scene, the 3D scene. So again, I've kind of paraphrased some of this thing from the spec because it is quite kind of verbose, the way that they explain it. But basically, you need to be able to go to different viewpoints. I'm not sure lighting's critical. You know, we're not really, as long as the parts are visible, then that's the main thing. I don't think we really need to change lighting as long as everything's visible. But you might need to put different viewpoints in there. But as you can see, like they mentioned something called kinematics and so forth. You know, a lot of these things have really got nothing to do with publishing it for somebody to get information from a technical publications point of view. So they have some specific guidance around text in the 3D viewer. They say it should always remain horizontal and should be facing the user. So another word is called billboarded. So as we move the model around, the text should move, but it should always remain facing us. So it shouldn't kind of go the opposite way around, or shouldn't distort in any way, which is a challenge for a viewer. It's also, the text can be used to warn the user. It should also be used probably for call outs. So you can add a call out to the 3D model. And also the animation, if there's any animation involved, that it should be realistic. But it really should be done in a way that it kind of adheres to the textual information as well. So it should explode in the right. If it's pulling something about, it should do it in the right order. So they have certain defined view modes. So the most common would be isometric. So this is what the viewer should do. So there's a kind of a lot of, it's almost like a guide rather than a guidance for the author of the information. It's almost guidance for us as a technology company or an internal technology department within a company of what you need to do from a viewer point of view. So which is quite interesting. So it's rather a technology thing rather than a creation point of view. But isometric is still predominantly, you should have a view for isometric that you can go to pretty much straight away in the viewer. And you also should be able to see like a model tree of some description. So, and be able to actually interact with that model tree. So one of the things because we are in kind of the same position as everybody else that we thought we better choose a 3D format to focus on for our customers who want to deliver this data. So we looked at X3D, which again is an XML format. Although it's good, it kind of, it's not good in respect of it's a large file because it's text based and it renders quite slowly. So there's some definite challenges there. And VRML, which has been around a long time, is really was superseded by X3D. So we didn't really think that would be suitable either. And then with PDF, although PDF's, again, open, but it just didn't seem the right environment to try and put that as part of an IETM, which could be web-based. So what we did is we selected GLTF. So GLTF is an open format. It's managed by an organization called the Cronus Group. Then you can go to look at them online. So it is a 3D publishing format. It's got two kind of iterations of the file format, GLTF, and then GLB is like a binary, but they're basically the same. It's just they kind of formatted it or exported in different ways. But it doesn't need a plugin. It can go straight into a web browser. It's really efficient displaying the file and loading them in because of the optimization of the 3D file via compression. And interestingly, Microsoft do support it as well. So although not crucial, we thought it was good that somebody was behind it that was of some size. So this is actually, I'm still in PowerPoint here. So this is a GLTF file within PowerPoint. So you can see they do have support for it. Plus they do have views and things like that. So you can say, I want to go to the front or the end and so forth, and pan and zoom. So although it wasn't crucial, it was something that we found interesting that Microsoft were supporting it. And that kind of hook line for GLTF is it's the JPEG of 3D. So if that's the case, then it's definitely going to work in the web. So what did we do? Like we said, we supported Vizex Edit 3D, the file format GLTF within there. So let's go to the final demo. And we'll also do a preview of what we've been doing some work around the 3D viewer as well. So let's go back to Vizex 3D. So this is really a really simple file. So we're in Vizex Edit 3D. So this would be really our authoring side. So if we want to add an annotation to this, we can add, and then we drag out, and we can add an annotation to this particular file. So, and we've just put in things like types and so forth, different types of information. There might be a caution or a warning or just information, and then we can give it a title. Let's make it a warning. In fact, I should have said a warning, shouldn't I? But anyway. So we can make that a warning. So this would be the title of the annotation. So then we put that into our 3D illustration. So as we move it around now, you can see that it moves with it. And it even will do this if I go into, if I explode it, it will still go with that particular part. So it's really attached to that part. And we're still kind of adding to this and working on this, but we thought that was a good starting point, that if you're going to do a 3D, you're going to have to attach some information to it. So the next part really is the fact that we need some way to view this. So I mentioned we can export, and we could export this as a GLTF file. So we can see we have that option down the bottom. We have the GLB as well as an option as well. And both will support what I'm going to show you in a second. But we did support X3D files and so forth, so we do support that. We just at the moment think that although you can create the files, they are not as optimized as GLTF. And they probably never will be because they're in a text format. So if I go to the viewer that we have here, then we can see that we have the text in here, the annotations that we might have created. We're just working on having different colors. When I hover over the part, it highlights the part as we move over it. We have the model tree, which is exported along with the GLTF. So this is just in Chrome. So now we have our illustration or 3D illustration, and we have our model tree. So if I want to highlight the punch, then I just click on it, and it takes us to that view, the side rod. So whichever click on, it will take us immediately to that. So we have that interaction between the model and the model tree. We also, if I go to the base here, you can see we can break this down, and then we have the annotations. So if you want to bring the annotation to the front, and I don't know if you can see that it also it billboards it. So if I just move in a bit, you can see that the text moves around and stays facing us, so we don't lose that. And the model tree here, you can hide parts as well, so you can hide that away. So you're just left with the base. So this is work in progress, but I think it shows you the possibilities of actually taking this information out in a format that's open, but also adding the information that you're going to need in a technical publication as well. So that's the first time we've actually shown this technology and it's not released yet, but we're still working on it. So if anybody wants to put any input into it, then great. We're still working on the annotations so they become clearer and so forth. So I hope you enjoyed that. Okay. So in summary, it's a lot of information that we put out there today. It's kind of a high level, but hopefully it helps and certainly steers you in the right direction. Everything we've shown today, we pointed to in the spec. So when you get the slides, you can do your own research and so forth. But as I said, we're at kind of a project as well, because we have to comply to S1000D as you would, but ours is from a software point of view. So we're kind of all in the same boat. So our primary focus is really developing solutions that comply to the specification, and also extending our knowledge out as well that we find to the end users, yourselves as the audience as well. So VisX Edit is one of our primary tools for 2D technical illustration. Then we have VisX 3D, which is self-explanatory, but also that can be standalone. You don't have to have the 2D part. You can just have the 3D part. And then the 3D viewer we've got in development is probably going to be a software development kit. So it's going to be something that you would implement within your IETM, or a vendor would do that on your behalf, depending on if you create your own IETM or not. But we're continually developing that at the moment, so we'll have more information on that as we go along. So we're continuing to study the spec. I don't know if there's going to be version 6 next year, but we'll have to wait and see. And we consider ourselves still compliant with the specification as well. We always attend the events, especially in North America and sometimes in Europe, and we will definitely be participating next year's user forum in 2022. So hopefully we'll see you there. Okay, so I'll bring Don back on. So please send us your questions. It'd be good to have some kind of interaction. Obviously, we're not talking to you directly, but it'd be good to hear some questions from you. And let's just fire away. You there, Don?
Yes, I'm here.
Okay. Okay, so the first question is actually about the product, which was VisX Edit. So it says, can it directly import CAD models to flat illustrations? I think I did show that. I'm looking at the timestamp on the question here, and it's yeah, I don't know if I'd shown it at that time. I can't, possibly not. So VisX Edit 3D is the way that you would import, or the software where you would import the model, the 3D model, and then you would actually create the 2D from it. So, and that was a step file. So I think, yeah, I think I did cover that after the question. Okay. So the other question was around the spec itself, about the support of SVG in the spec. It's difficult to say if they will document the SVG format. I think, Don, did you speak to anybody about that? Actually, SVG going into the spec as well?
Yeah, I mean, there's been some interest in it, but it's like, you know, there hasn't been enough, I guess. You know, that's the thing with standards. It requires people to do groups to do some work. So, you know, not a lot of volunteers, but we have offered to provide our profile as a basis, and I think it's a good starting point. So we'd like to do that. And if any of you have contacts or participate in the S1000D graphics working group, you know, maybe you can, we'd be glad to partner and initiate that. So, yeah. So yeah, there's some hope there, but
Yeah, our biggest challenge is from a software developer's point of view is that with SVG is we're kind of constantly modifying our conversion tools for SVG to suit certain customers' files. If they were all done exported in the same way, they'd be completely interoperable. So that would be a big benefit. But in saying that, in the defense of SVG, it was never designed to be a data exchange format. So it's I'm not sure how you defend the file format, but that would be my defense. Somebody asking how they would get involved with testing and suggesting for the development of the 3D viewer. Yeah, I think we will definitely open that up. All our SDKs have evaluation versions. We're not quite there yet with this, but if somebody wants to set up an individual presentation for them, then we'll be happy to do that. And then if you have suggestions, then it'd be good to get some feedback from the wider community to help us try and put some requirements in that we feel are needed. So definitely we're open to that, and I'll probably the person who asked that I'll probably email them after the presentation and we can sort something out. Can we interact with lighter versions of CATIA and integrate this into the PLM difference CAD packages? We don't support any native formats. We only really support STEP. I would probably, we're not really providing tools to modify the models themselves. We're really, what we're doing is utilizing the model to create the publishing format for either 3D or 2D. So we would probably never recommend our tools to change the source data of the CAD. That wouldn't be something we would want to be involved in, really. And I don't think the CAD engineering departments would want us to do that either, if that's what the question is. So if I'm answering it, if I'm misunderstanding the question, then I apologize. Please write to us in an email independently, and we can talk about that. Oh, so not changing the source. You can't, if you're talking about having support for CATIA within the 3D viewer, then no. You would need to, we'd need to kind of process that using STEP, and then bring it into the Vizx Edit 3D, work with it there, and then export as a GLTF for the viewer. So that's how you do it. We had quite a lot of questions about support of Vizx Edit 3D supporting native formats, and we have looked at it, and we still haven't come to a decision if we're going to support native or not. Would you agree with that, Don?
Yes, yeah, it's yeah, what we do now. I mean, there are some inexpensive conversion tools to convert, like you can accurately convert CATIA to STEP, because STEP can carry everything. So there's a tool we can recommend to convert them. And it's, if we get down the line, we may build in some support directly for CATIA. CATIA and SolidWorks are the two that we run into the most, I think, and those would be probably the ones we'd address first.
Okay. Thank you, Don. Well, if anybody, thanks for all the questions. If anybody has any more, then or they want to send us via email, please do so. And we will definitely be in contact with our last questioner. We will send you the details on the converter. I think Don will be able to do that. That's
yes,
the
I can do that.
Okay. So thanks everybody. We've been going an hour, so I appreciate you spending all this time with us this morning. We had a tremendous turnout, and it's really good to communicate these kind of different times, communicate with our end users, customers, prospects, whatever. So thanks for attending today. Hopefully it's got all the information that you needed. We have recorded it, so I'll be putting something up on LinkedIn tomorrow. It'll be on our YouTube site. So if you want to give it to a colleague, then that's fine. And I'll also timestamp it so you can miss out the boring bits. Okay. So thanks, everybody. Stay safe, and we'll look forward to seeing you in our next webinar. Thank you.